Hello friends, this is Durga again from Technology Mentor / ITversity, and as part of using a single node VM to set up plain vanilla Hadoop and explore Hadoop core components, HDFS and MapReduce, etc. We have seen how to build the VM by cloning it from the template and set up all the prerequisites, download Hadoop binaries and also the source code. And also we have seen how we can update Hadoop env.sh to set the Java home to right location, which I will re-emphasize in today's video also. And also we have seen how we can actually compile our Hadoop source code to generate native libraries, especially for compression algorithms. And as part of this video, we will talk about HDFS little bit in detail. And then we will see how we can actually set up HDFS on the single node cluster. As of now, when we run Hadoop fs-ls command, which will help you to list the files in HDFS, if you run it as we have not started the cluster yet, it is actually getting details from the local file system. If you see ls-ltr here, there is one directory here, and it is the same information it is showing up using Hadoop fs-ls command. But when you actually set up Hadoop daemons like Namenode, Datanode, etc. on this VM, instead of looking at local file system, it will start looking at HDFS file system. So that being said, let's see what HDFS is, and then we will talk further on this. So when it comes to Hadoop core components, the foundation is HDFS. And if you want to see more details about this, you can go through my other videos. I have big data introduction, I have Hadoop administration videos, and there are several videos which talks about Hadoop introduction. You can go there and look at that video to understand what Hadoop is. And also I will try to embed that video as part of this playlist also at appropriate location. And at the bottom you have HDFS and then MapReduce, and there can be non-MapReduce programs also. For this we don't need to worry about the rest of the components. We will be primarily focusing on HDFS and MapReduce and probably few of the tools over time, not in immediate future. So when it comes to HDFS, HDFS is a distributed file system in which a file will be divided into blocks, and those blocks will be distributed on multiple nodes in the cluster. As in our case, we have single node, we have only one node where the files will be storing. And to support the files to be physically stored on a node, there will be a Daemon process called Datanode. And then to have the mapping between the file name and the physical physical files which will have cryptic names like block IDs. To have that mapping, there is another daemon process called Namenode, and there is also a helper node called secondary Namenode. So to set up HDFS, we need to have this daemon process running. So if you are familiar with any of the software technologies, when it comes to setting it up, first you need to download the binaries, which we have done as part of earlier videos, where we use wget and download the binaries for our Hadoop software. And then you have to install it. We have done install also by running tar xdf command and untar all the directories wherever we want. And then the third part is configuration. And the fourth part is to start the daemon process to support your technology. Take the example of Oracle. Oracle also you have to download the binaries from Oracle website, and then you have to configure. You have by updating init.ora and other parameter files, and then you have to start the services so that Oracle database will be up and running, and you will be able to connect to that and interact with them. So these four steps are common with any software technology: download, install, configuration, and start the daemons. Okay, so we have already done download and install. Now we are talking about configuration. So for each technology, the configuration can be different, but the approach is same. There will be a common location where it is part of the documentation, or there will be some default locations which will be explained in the documentation. And as part of Hadoop, if you go to Hadoop directory, which where we have installed Hadoop software and run ls-ltr command, there is a directory for called bin, and bin have all the commands like Hadoop, MapRed, etc. And on top of that, there is another directory called etc. So if you go to etc, and there will be subdirectory called Hadoop on that, and if you do ls-ltr, there are a bunch of XML files, sh files, etc. And when it comes to HDFS, there are 3 XML files that are important. Sorry, 2 XML files and 1 shell script that is important. So the shell script name is hadoop-env.sh, and it will control the environment settings for your Hadoop to run. When we say environment settings, the memory settings, the class paths for other dependent technologies, etc. is considered as environment, and those settings related to those are part of hadoop-env.sh. And then there is a file called coresite.xml, and if you are familiar with the Hadoop architecture, Namenode is the most important thing. If Namenode is down, you cannot do anything on the cluster. And Namenode is used by many technologies, not just HDFS. So for that reason, those parameters which are required for Namenode, which is required for other technologies also, like MapReduce and many other technologies in Hadoop ecosystem, those parameters should go to coresite.xml. And one of the important parameter in coresite.xml is called as fs.defaultfs, and we have to have IP address and port number to understand that to understand where our Namenode is. And then there is another XML file called HDFS site.xml. So these are the 3 most important XML files. As of now, you will have many entries on env.sh, and we already seen how to that we have to set up java_home to tell where our Java is for to Hadoop, and you see bunch of others also. So whenever you want to play with memory on this VM while running Hadoop, you have to understand the relevance of all these parameters. By default, Hadoop heap size is 1 GB, and if it is saturating the resources, you can decrease it to 512 MB or whatever value you feel is relevant. And also there are many other parameters which you need to explore over time. I will not be able to cover all those parameters. And then the next one is coresite.xml file and HDFS site.xml file. Both are empty, so there is nothing except that a configuration tag. So it uses certain defaults and try to bring up the cluster. So if you want to start the cluster, first what you have to do is you have to do Hadoop Namenode format, and then it will use localhost and try to format it, but you might run into some issues, and I will not recommend you to use this path even by leaving everything as default. Even if it allows, it is not the practical way of doing it. To understand Hadoop at a broader level by using our VM as simulator, I will highly recommend you to update these coresite.xml files with different types of parameters and then start the cluster. So if you go to this URL, so you can search for Hadoop 2.7.1 setup, and you can go to setting up a single node cluster, and here we are actually doing fully distributed mode. So click on that, Okay, yeah, click on that and you can see cluster setup link over here. You can click on that and then you can see lot of details over here. So all these parameters are from Hadoop env.sh. You need to be familiar with all these parameters over time, not immediately. They are primarily memory and environment related stuff. And then comes core site.xml and HDFS site.xml file. So first we will try to update core site.xml file with this parameter ff.defaultfs. So vi core site.xml. So under configuration, you need to have a property tag. And under that, you need to have two tags, name, at least two. You can have more like description and final, which we'll see later, and then value. Okay, and then we have to put relevant parameter here. So the parameter is fs default fs, and value is our Namenode IP address. In this case, our Namenode IP address is HDFS : and Hadoop 271.itversity.com and then port number 8020. You can give anything, but default is 8020 and I am using default port number itself. And there is a so when you actually define like this, you need to make sure that when you run hostname -f command, it resolves to that one. Either you need to use DNS or you have to update etc host file to get this one. If you don't have etc host file or not defined in DNS, you will not see in the fully qualified name by running hostname -f like this. And whatever it gives, whatever IP address it gives here, you should use that in your core site.xml file. Okay, and also we will add another parameter. So for that, I am going to this line where I have property, and you can actually copy or yank multiple lines using YY. YY will yank only one line, which means copy one line. If you want to do multiple lines, you just have to type Y, whatever number of lines you want to copy, in this case 4, and then Y. And if you can see that it says 4 lines anchored at the bottom. And then go to escape mode and scroll down to the last line where I want to copy it, and you have to say Shift P to paste those 4 lines, and you can see the 4 lines here. And now I want to give this one also. So io.file.buffer size will come into picture whenever you want to write a file into HDFS. The file will be divided into buffers, blocks, and those blocks will be copied into HDFS in the using the buffer size defined here. So this is the buffer size. Okay. Now that being said, let us define the DFS Namenode name, dir, and other important parameters in HDFS site.xml. If you don't define these things, by default it will go to temp directory, which is not very good location. So for that, let me create a location here, directory here. I will do mkdir name, mkdir data. So name for Namenode, and then mkdir secondary. So 3 locations, 3 directories I have created, and all these things have to be represented, defined in HDFS site.xml file. And let's do that. So first I am actually defining the Namenode directory. So again we need to have property tag, name tag, value tag. It is very important that you don't have typos here. If you have typos, you will see all kinds of issues. Okay, then I want to copy these templates multiple times because I have many things to take care of. So first, let me give this DFS name node directory, and that is slash name. It might fail, I think. I think the directory should not be there. Let me do one thing. So let me say HDFS name. I will create the directory, and let me take care of this mkdir HDFS, and then I want to move all the directories name to HDFS, mb-s to HDFS, secondary to HDFS, and also data to HDFS. Now I can only have the parent directory, means I can have the name node directory like this, and it will create at the time of formatting our file system. Only the parent directory should be there. Okay, and then I want to create directory for Datanode, and it is HDFS data, and then I want to have another parameter okay, I need to have Google secondary name node directory. I think it's dfs dot secondary dot name dot dir. Yeah, so it should be dfs dot secondary dot name dot dir. dfs dot secondary dot yeah, I think it is this one, dfs dot name node dot checkpoint dot dir. We will see if even if it is having issue, we will take care of it. We will take care of it later. And here we will say HDFS and secondary. Let me see the location. Yeah, that is right. And then let us delete these things. D12D will delete 12 lines. And now we have set up core site and HDFS site. And now if you look at our environment variable, sorry, if you look at our path, it is pointing to two locations in Hadoop. One is Hadoop bin and one is Hadoop sbin. Bin will have all the commands and sbin have scripts. So to sbin have scripts like start dfs.sh, so we can invoke that without going to that path. If you are not able to run this command from wherever you are, that means the path is not set properly. You have to take care of it like this. You have to append to the path in your bash profile, and then you have to run the script and by giving dot space tilde slash dot bash profile, and tilde is on the left side of the key which have 1 on top. and then you can run start_dfs.sh, and it will prompt like this. Okay, I haven't set up passwordless login on this. That's why it is asking for password. Once I set up passwordless login, it will not ask for this. I have covered that as part of the last video. So if you see, the logs are being written to this location, root Hadoop 271, and there is a directory for logs under our parent Hadoop home directory. And all the logs will be generated over there. We will see the log location also, and we can actually customize to redirect log to wherever we want, which I will not be taking care at this time. I think now it will not start because the issue is I have not formatted the name node. When we actually set up the Hadoop for the first time, first we need to do the format. So let me stop all sh. It will take little time to stop. So I am running SSH keygen so that I can set up the passwordless login, and then .ssh .id rsa .pub. I have to redirect to all the keys in that. Hit enter, and now let me stop all. Or I can even do stop_dfs.sh if I just want to stop name node, data node, and secondary node. So if you understand properly, the configuration is done by changing certain things in XML files, and then as I mentioned to you, the fourth step while setting it up is to start the Daemon process. And to start the Daemon process is for HDFS technology. You have to you can use this command called start-dfs.sh, or there is it's just a script of actual Hadoop commands. You can go and look into that script and understand what actual commands it is invoking. Okay, now to format, after modifying our configuration files, you have to run command called Hadoop Namenode and format, and hit enter. Okay, there are no errors here, so format went fine. And let us see if it has created any files under HDFS. All the directories, we have not created these directories. We just, okay, we have created these directories. I think I should not have created this. Okay, let me check. Yeah, that's fine. Even though I have created the directories by moving from slash to HDFS directly earlier, it is formatted successfully. You can see this message here that and the HDFS name is formatted successfully. And let us see what is there in data. As of now, it is empty. Now I will actually do the start_dfs.sh. And while running it, you can go to you can open another session, and as I mentioned to you, the logs will be under root Hadoop logs, and for each of the type of Daemon process there will be a log file. And in our case, we if you want to see the logs for name node, you can copy this file name tail-f and paste it, and then you can see what is going on. If you want to open the file, you can do the view and see whether it is started if there are any issues. If you want to see all the information that is being logged into that while it is running. Tail-f will be updated whenever there is a change to the log directly. If you want to come out, you just hit Ctrl+C. That being said, the name node is started. Now it is starting the secondary name node. Let us see tail-f and then give the path to confirm if there are any errors. I think there are no errors here also. Here, and there are no errors here also. Secondary name is also started, and even Datanode is started. So to validate whether the Daemon process are up and running, you can run a command called ps-ef, and then pipe, and then grep Namenode, and you will see something like this if the Namenode is running. So one is for Namenode and the other one is secondary Namenode. Even secondary Namenode have Namenode in that. That's why it is showing up both. And then if you want to see whether the Datanode is running, you can run this command and you can see that a Daemon process with Datanode is also running. So now everything is running properly. Earlier, if you remember, when we run Hadoop ss -ls command before starting these daemons, it has returned the files on the OS. Now let us do that here, Hadoop ss -ls, and hit enter. It says no such file or directory, because when you run this command, it will actually look for, when you do not specify the path, it will by default look for this path. And if that path is not there, it will complain that no such file or directory. So let's see if there are any files at all by doing Hadoop ss -ls. Slash is the root file system even in HDFS, and hit enter. So as of now there is nothing here. We can create directory structure here by saying Hadoop ss -mkdir -p to create all the directories in the path specified, and then hit enter. Now the directory user and also subdirectory root is will be created. And if you want to see the permissions on the files, you can say chmod and /user. As of now we have only, not chmod, let me do the ls. As of now we have only one user on our VM, which is root, and everything is owned by him. Whereas in distributions you will see different types of users for each purpose. HDFS will be typically under HDFS. You can simulate that on our VM also, but I don't want to go that far, because we are just using this VM for R&D purpose to write MapReduce programs as part of your assignments and all those things. That being said, now we have this user and root, and if you look at the owner for this directory in HDFS, the directory is root, and this path will not exist in local file system, because we are actually accessing HDFS file system. So if you want, you can try ls -ltr /user, and there is no such file or directory, because here when we invoke Hadoop ss command, it is actually looking for the directories and files in HDFS, not in the local file system. And this is logical file system, and whenever you copy a file to this, it will be copied differently than traditional files in OS, which is covered elsewhere, and I will try to add those videos after this, so that you can go through those and understand how it works a little bit in detail. That being said, our single node Hadoop cluster with all HDFS components is up and running right now, and we will see how we can leverage this to develop MapReduce programs going forward. I hope you are enjoying the content so far on my channel. If you like a particular video, please click on the like button, and if you want to provide feedback or ask any technical question related to a particular video, please do so. And if you have not subscribed to my channel yet, please do so. You will see a lot more content than just Hadoop and big data on my channel over time. Thank you. Bye.